Alright, so back with continuation of my keyer project. So I was able to find out that the Digispark board does not have serial output, but one thing you can use is you can use this Digi keyboard. So I basically added a new parameter here. So use Digi keyboard for debug printing, and so I have that set to 1. And basically what that will do is I just have it printing out the speed, and essentially it acts as a keyboard. So as long as it's connected, I just have it dump data into a like Notepad++, is what I'm using, and it'll basically output whatever is being printed here. So what I have it doing now, I was able to get it connected and printing out. I have it printing out 2 variables. I was curious what the actual input here in analog read was. So I'm basically doing an analog read and then also using a map, which it's working perfectly. So I've got basically my analog read set up, which reads from 0 to 123, which these are the values. So initially I was wondering what this does, but essentially, so the analog input pin that I'm using here, which is I'm using let's see, so on the Digispark it's actually pin P2, but in the program I have to set it to A1. So I googled and there was a mapping from A1, which is actually pin P2 on the Digispark. So I have that set up, and what I can do here, so if I have it running right now, so if I plug this in, what I should see is basically output into my keyboard here, because it's essentially doing the Digispark keyboard output. So let's see if it works. Once I plug it in, yep, there we go. Alright, so we've got data. It's a keyboard essentially. So if I rotate this here, so if I rotate it all the way down to 0, there I'm getting 0, which I mapped it to 1. So the one challenge here is once you have this plugged in, you got to keep your cursor in your text editor. Otherwise you end up with data coming over here, as you can see. So, actually that's nice. I can use my scroll wheel. So, I'll have to control Z this later. But I am printing out. So I did the map, analog read, and I mapped the values from 0 to 123 or 1023 to 100 to 5,000. So it basically just does a linear mapping. So if I rotate this knob here, so I have this potentiometer, just rotate this, and we can see those values going up there until I hit the max. So I hit the end there, 1023, and it outputs 5,000. So, yeah, pretty cool. And so basically the way I have this set up, I just have, so the center pin of my potentiometer, I have connected to the data pin, so that's connected to A1, and then basically on each side, so I have each side connected, one side to ground and one side to 5 volts. So it basically acts as a voltage divider, and it's reading that voltage from a value, basically from 0 to 1023. So, if I rotate that up, get it to go up. So, have that working there. So next what I'll do is I will connect Probably connect my DIT and DA pins, which over here I have connected as pin SW0 and pin SW1. So I'm going to do a little more soldering and get these pins here connected. And then those will be connected to pins 0 and 1 there. And then I will also need to connect a ground. So I'll probably... Actually, I think I'm going to flip these around because based on how I have this soldered up right now, in order to get... actually, you know what? I might be able to reverse these. Essentially right now, if I have my speed knob turned all the way down, in order to get a 0 value, I have to have this one pin that I have connected to my brown wire and have that connected to the 5 volts, which I really don't want to because brown typically is usually for ground. So I think I might flip that around, but I was just thinking about it, and I might actually be able to flip that around by just swapping these numbers here. So I might be able to do my mapping from 1023 to 0. So I'm going to actually, you know what I will do? I am going to unplug this so I'm not getting my keyboard out. So now my keyboard, you can see, stops there. I'm going to clear that out. And I'm going to Control Z over here to undo when I hit the cursor there. Alright. Okay, so I'm going to flip these around. I think what I'm going to do actually here, I'm just going to say define reverse pot or speed. So I'm going to say yes. And essentially what I'm going to use this for, actually I'll call this reverse speed map. So I'm reversing the map. So I'll take this. And what I'm going to do here, I'm actually just going to make 2. So I'm just going to say if reverse speed map equal. So I've been programming. I love Python because Python will basically determine if that's a 0, it'll reverse it. If not, it won't. I'm not sure if that works here or not. So we'll see. So one thing I've learned over a decade of programming is readability is really important. Like one of the things that I really like is I read this, I think in Google, they were like, you're going to write code once, but you're going to read it 100 times. So readability is important. So I try to make my variables readable, try to make my code formatted well. I feel like it's just kind of just having good code hygiene. So try not to get on my soapbox too much about it, but I do feel like it is really important, especially if you're trying to work with other people and have your code out there for other people to see. You know, it's kind of like write clearly so, you know, people can read it and understand it, and they're not having to spend a lot of time, like, you know, kind of figuring out what a line means. Like, you know, have your variables be readable, have your function names readable, your method names readable, everything. So, you know, here I'm saying speed equals map. So map is going to map something to something else. Analog read. And then my variable here. So this is my, I know I'm reading my pin of speed potentiometer. So pin speed potentiometer. And then here, if I'm reversing, I'm going to, so I theoretically could reverse either of these, I'm just going to reverse this one and we'll see what happens. I was reading the API documentation for this, and I think it said you could reverse either of these. So we will find out here. All right. So upload. All right. So again, I need it to, and actually I'm just going to put my cursor over here. So plug it in, should upload, and then once it's done uploading, I should start seeing output. And there we go. All right. So we got output here. So I'm now at 0. Perfect. Or let's see. Actually, I guess that kind of depends on what I'm going to do with my speed variable. So I'm getting 0. It's actually not reversing it, is it? Oh, no, I guess it is. It is reversing. So I actually got to determine, and this is kind of a programming thing for how I'm going to write my project here, where I'm trying to make this generate code, Morse code. But this kind of depends on what I'm going to use my speed variables for. So I don't know if I was going to actually use it for like the code speed, or I know in the algorithm that I had here that I posted in the chat, or in the description of this, there's a link to another project in which it transmitted Morse code, and so that's where basically the next thing here I'm gonna have to figure out, so that I can move my cursor again. I'm gonna get rid of that. But basically the next thing I'm going to do is determine how to generate Morse code. And so a couple things I'm going to have to think about with this. So one, I still got to determine how I'm going to output to the speaker. I was reading some posts after doing some Googling that basically were saying like you shouldn't directly drive a speaker. So ideally you want to put a transistor in front of it so you don't blow it out, but you can technically do it as long as you have a resistor in series with it. So I may see if I can find the resistor. In my next video, I will post a little more about this and see if I can find this. Actually, here we go. So yeah, I found. So in my next video, I'll go over this. But yeah, basically, I need to wire this up so that essentially I end up with probably a resistor in there. For the first part, I'm going to do probably just this circuit A. Eventually, though, I probably will actually use a transistor or something. So it looks like this can be used. Too loud, connect to resistor. So the other thing is I have this volume control, which originally I was thinking of making this a digital control, but I may just make an analog circuit and just use that as a volume control, which actually would probably be significantly easier. And then, so a couple things I gotta, once I connect these switches here, which I think that's the next thing I'll do in my next video, get the switches connected. Then once I have the switches connected, then I need to generate the sound. So essentially what I'm creating here is a code practice oscillator to make that'll make a sound, and then eventually, so the other thing here is it has this transmitter RCA jack on it, which is for outputting to the transmitter. I'm probably going to see if I can salvage this read relay off of the original Curtis 8044 keyer board. I know these are good for driving transceivers. And this actually just has, so the nice thing with these, it's got 4 connectors here. So you basically have the output here, which is where that went to originally. And then that one went to the ground. So it basically just grounds it. So it's a switch, but it's driven by this. So it's not too loud, like you can kind of hear it, but since the reed switch, they tend to be pretty fast and pretty decent. So, because I mean, with Morse code, you're not going to be sending super fast. I mean, even if you're sending it 35, 40 words a minute, the reed switch can keep up with that. So, yeah, next video, I'll go through the switches.